So when we look at the isotopes of iron, we see these ratios of abundance, okay? 54 is 5, 56 is 91, 57 is 2, and then a little bit of 58, and then just little tiny bits of the other element, of the other isotopes, right? So what we're going to discuss today is the average elemental mass, all right? Average elemental mass. So if we pull up our good old friend, the periodic table, so pull out your periodic tables, take a look at them. Whoop. If we look at iron, so we see these numbers here. Don't worry about these numbers over here quite yet. You can see, so we have 26, which is our, what is the name of this number? Wilkes. This is the atomic number. Of course, we have the atomic sign. This is the name of the element. These, don't worry about these right now. This is the number of electrons that it has in certain places, but we'll talk about that later. This is the average elemental mass. Okay, the average elemental mass is 55.845. So remember that the mass of any one atom is always a whole number. The average of, or not the average, the mass of any given atom is always a whole number because you have protons, which weigh 1, and neutrons, which weigh 1 atomic mass, right? And you add those together, and you can never have partial protons or partial neutrons. Therefore, the mass will always be a whole number in atomic mass units, okay? But this is not a whole number. That is because it is an average, okay? So for instance, who's ready for a classic math story problem? If Sophia has 10 apples, and let's see here, Reepy has 6 apples, and Ryan has 7 apples, okay? The average number of apples that a student in this class has, and those are the only 3 students that have apples. In fact, they're the only 3 students in the class. So what was it, 10? Reepy, how many did you have? 6? And Ryan had 7, right? You average that out by adding them together, right? And then dividing by 3. That gives us an average of 7.66. Did any of you have 7.66 apples? You should all be shaking your head in disagreement. No, you did not have 7.66 apples. You all had a whole number of apples, but the average between the 3 of you was not a whole number, okay? It was a partial integer, okay? This is the same deal here, okay? And in fact, I believe that we can look at boiling point, ionization, heat, abundance. No. There should be, does it not give me a, does it give me an option to look at common isotopes? I feel like it should. I feel like there is a way on ptable.com to look at common isotopes. And if there isn't, that is a huge, oh, not borium. Well, oh, isotopes, aha, thank you. We found it, everybody. We as in you guys, not me. Okay, iron, whoa. Whoa. This is fun. What is that? Oh my gosh. This is crazy. Whoa. Okay. This is cool. So look at all these different isotopes. That's pretty crazy. 56. So it tells us the so your binding energy, right up iron 57, iron 56, mass. So 56 is the most common, right? So you can see on the left here, you can see abundance, right? So 54, 56, 91.754. 55 is 0%. It's so then 54 is 5.845%. And this is crazy. That is a weird way to do it. So there's a lot of isotopes of iron. Really, I mean, you can screw around with the number of neutrons. You could bombard some iron atoms with neutrons and just make an iron like 80, right? An iron with a mass of 80, if you just add a whole bunch of neutrons, it wouldn't be there for very long. This is cool though. Let's look at carbon. So carbon 12, that's the most common one, 98.89%. And then if we go to 14, 14 is very, very rare, 0%, and it carbon 14 is actually, it's super rare, but we use it for carbon dating, quote unquote, to determine how old things are. So this is cool. Carbon 13, carbon 12. Okay, cool. So that's fun. So if we go back to our isotopes of iron thing here, if you don't have a calculator, you should get yourself a calculator. If you do have a calculator, pull it out. You'll need it for today. So I'll give you a second. Find yourself a calculator. Or grab one from me. Okay. So we have iron 54. So iron 54 is 5.8% of the isotopes of iron, right? Yes, yes, Mr. Kershaw. Okay. So when we look at these, I'm just going to make a quick little table here. Iron 56 is 91%. Iron 56, 56. And then iron 58 is 0.2%. So 5. Oh, wait, I forgot 57. 54 is 5 there, not 56 is 91.75, 91.75. And then iron 57, 2.12. Okay, so when we look at these, we can determine percentages, or we can look at the percentages, and we can figure out what the average mass is by the percentage. Okay? What does that mean? It means that we can, the way that chemists determine the average mass of an element way the chemists determine the average mass of an element is by looking at this, okay? So I'm not going to get into how they determine the mass of the isotopes, or like the abundance of the isotopes. It has to do with something called spectroscopy, which is pretty cool. So with your calculator, I want you to multiply 54 by 0.0585. Okay? And then you can hit enter or equals. And I want you to add that to 56 times 0.9175. 56 times 0.9175. All right? Then you can hit equals again. Then I want you to add that to 57 times 0.0212. And then I want you to add that to 58 times 0.0028. Did we follow those instructions? Maybe? It was a lot? No, it's okay. It's all right. So if we go over to our periodic table, iron has an average of 55.875. Me just taking the four most common isotopes of iron, multiplying their abundance by their mass, gave me an average of 58.9, so it was rounded up a little bit. It's very, very similar, okay, 55.9. And the actual, sorry, I got to click on it here. The actual, oops, not isotopes, is 55.8, okay? And I got 55.9. Very similar, okay? So that is how it is determined. So let's run through that one more time. So we're going to do isotopes of carbon. Isotopes of carbon. Okay, here we go. So carbon really only has two common isotopes. All right? So how are we going to do this? Wilkes?
We times 12 by 0.989. And add that to 13 times 0.011.
Yep. So 12 times 0.989. And then add that to 13 times 0.011. And that gives us 12.011. We go back to our periodic table, click on carbon, look at that. The exact same answer. 12.011 is the average mass of carbon. Do we see how that works? You take the percentage of you take the abundance in a percentage and you multiply it by that abundance's isotope, which is the mass. And that will give you the average mass. Okay, so let's run through that in terms of, let's do that together. Okay, so it was 12 multiplied by 0.9, oh boy, 0.989. I know that's technically the wrong way to do an 8, but yeah, Mrs. Snyder, my first grade teacher, really tried to get me to change that, but you know what, whatever, it's the way it is. Okay, 12 times 0.989, and then 13, so you add these together, 13 times 0.01, what was it, one, yeah, just one. 1. Okay, and that gives us 12.011. So this is the average mass in AMUs. AMUs. And this is for carbon. Okay? Do you see how that works? All right, so here's what I want you to do. I want you to find an element. Okay, I want you to find an element on the periodic table. And I want you to find its isotopes. So for instance, you could choose cobalt. And all you got to do is put in isotopes of cobalt. Isotopes of cobalt. And together, I'm just going to, oh wow, that's crazy. 100%. I guess cobalt is not a good example. What is the average mass of cobalt? 58.933. Yeah, that makes sense. 59% of it is, or not 59%, 100% is 59, and then there's a couple of just really small traces of something else. So find the what's the word that I'm looking for here? Isotopes of an element, and then do what we just did to figure out the average and see if it matches the periodic table. Ready, go.